take any crazy idea. Well, I don't know, it's hard to make up a very crazy one thing, witches or something like that, and you tell about what people used to believe in witches, and of course nobody believes in witches now, and you say, how could they believe in witches? Then you turn around and you say, oh, let's see, what witches do we believe in now? What ceremonies do we do? Every morning we brush our teeth. What is the evidence that the brushing the teeth does us any good in cavities? So you start wondering, are we all, imagine as the Earth turns on the orbit, there's an edge between light and dark. And along that edge, all the people along that edge were doing the same ritual for no good reason. Just like in the Middle Ages, they had other rituals. And you try to picture this perpetual line of toothbrushers going around the Earth. It's to take the world from another point of view. Now, it may well be that brushing teeth is a very good thing because it gets rid of cavities. And you can find out whether it does or it doesn't by trying to find out. Now, you can ask your dentist. He says, of course. And you say, how are evidence? I have not found the evidence from dentists because they just learned it in school. Now, I'm not trying to argue that it's good or bad to brush teeth. What I'm trying to argue for is to think about things from a new point of view. See, I have had in my life a number of pleasant experiences. The earliest one, when I was a kid, I invented a problem for myself, the sum of the powers of the integers. And in trying to get the formula for it, I developed a certain set of numbers formula for which I couldn't get. And I discovered later that those were known as the Bernoulli numbers, and discovered in 1739. So I was up to 1739 when I was about 14, you see. And then a little later I discovered something. I find out they invented a thing called, which we now call operator calculus. And that was invented in 1890 something. You see, I was inventing things that came later and later. But the moment when I began to realize that I was now working on something new was when I read about quantum electrodynamics at the time, and I read a book and I learned about it. For example, I read Dirac's book, and he had these problems that nobody knew how to solve. They were described there. I couldn't understand the book very well because I really wasn't up to it. But there, in the last paragraph at the end of the book, it said, some new ideas are here needed. And so there I was. Some new ideas were needed. Okay, so I started to think of new ideas.
Richard Feinman, Nobel Prize winner, and his son Carl stepped gingerly down the wet cobbles of Millbank, high in the Yorkshire Pennines. Feinman, professor of physics at the California Institute of Technology, retreats to this remote village near his wife's home for a special purpose. It's here he finds the time and solitude to sift the ideas that have made him the most feared and original mind in modern physics. Feinman is in the forefront of one of the oldest and most intriguing games of hide-and-seek in science, finding the ultimate constituents of the world. In this search, Feinman is a celebrated maverick who was encouraged by his father, a New York clothing salesman, to confront conventional wisdom.
One Sunday, all the kids were all walking in little parties with their fathers in the woods. Then the next Monday, we were playing in a field, and kid said to me, say, what's that bird? What's the name of it? Do you know the name of that bird? I says, I haven't the slightest idea. He said, well, it's a brown-throated thrush. He says, your father doesn't teach you anything. But my father had already taught me about the names of birds. We walked and he says, that's a brown-throated thrush. He says, know what the name of that bird? It's a brown-throated thrush. In German, it's called a Fliegenflügel. In Chinese, it's called a Qinglongtong. In Japanese, a Tohatahara, and so on. And when you know all the names in every language of that bird, you know nothing, but absolutely nothing about the bird. And then we would go on and talk about the pecking and the feathers. So I had learned already that names don't constitute knowledge, it's knowing the name of something. That's caused me a certain trouble since, because I refuse to learn the name of anything. So when someone comes in and says, You got any explanation for the Fitz-Cronin experiment? I says, what's that? He says, you know, that the long-lived K-meson disintegrates into 2 pies. Oh, yes, now I know. But I never know the names of things. What he forgot to tell me was that knowing the names of things is useful if you want to talk to somebody else. So you tell them what you're talking about.
But the basic principle of knowing about something rather than just knowing its name is something that you stuck to, is it?
Yes, of course. You have to learn. These are kind of disciplines in the field of science that you have to learn. That to know when you know and when you don't know, and what it is you know and what it is you don't know. And it's you got to be very careful not to confuse yourself.
How else did you try and
progress?
mold your methods of thinking, the way you looked at the world?
Well, we had a lot of little games, like he would say at the dinner table. He'd think of some little problem, and he'd say, suppose you were a Martian, we were Martians, and we came down to this Earth, and we'd look at it from the outside. And that, I can't explain exactly what he meant, but there's a way of looking something anew, as if you never saw it before, for the first time, and asking questions about it as if you were different. For instance, if you would ask, later I did some little amusing research for a paper in college on sleep, but it started with a question of his kind. Suppose you were a Martian who never slept. They didn't have sleep. You didn't have to sleep. And you came down to this Earth and you saw these people had this funny property that every day for a certain amount of time they had to lie down and become unconscious. And then the natural question would be, how does it feel to get unconscious? What happens to you? Ideas run along and suddenly they stop, or do they just run more and more slowly? But what happens to your ideas? How does it feel to become unconscious? So I tried to answer the question. What happens when you become unconscious?
But do you find that these days you still, when you're faced with a particularly difficult problem, when you're absolutely stuck, you tend to say, let's look at it like a Martian would look at it and
sometimes there are lots of things that people did. For example, Maxwell put the equations together. The Faraday, he formulated the equations mathematically with some model in his head. And then Dirac got his answer by just writing and guessing an equation. And other people got their answer, like in relativity, got the idea by looking at principles of symmetry. Now, all these methods, and Heisenberg got his quantum mechanics by thinking only talk about the things that you can measure. Now, all of these ideas, we should only talk about things that we can measure. Try to define things in terms of only things you can measure. Or let's formulate the equation mathematically. Or let's guess the equation. Or all these things are tried all the time. Look for symmetries. All that stuff is tried. All that stuff, when we're going against the problem, we do all that. That's very useful. But we all know that. That's what we learn in the physics classes, how to do that. But the new problem, where we're stuck because all those methods don't work. If any of those methods would have worked, we would have gone through there. So when we get stuck in a certain place, it's a place where history will not repeat herself. And that's makes it even more exciting, because whatever we're going to look at the method and the trick and the way it's going to look is going to be very different than anything that we've seen before, because we've used all the methods from before. So, therefore, a thing like the history of the idea is an accident of how things actually happen. And if I want to turn the history around to try to get a new way of looking at it, it doesn't make any difference. I don't care. The only thing that the real test in physics is experiment, and history is fundamentally irrelevant.
The most enduring legacy from his father was not just learning to question the physical world, but an enthusiasm for the inquiry, which at 54 Feynman still shares today.
It has to do with curiosity. It has to do with people wondering what makes something do something. And then to discover that